students, how are you? I wish all of you are fine. I am also fine by the grace of Almighty Allah. Dear students, last class we discussed about the energy, and today we also discuss about the energy, but today's term and last class terms are different. Today we discuss about the potential energy. Today's topics: potential energy. Dear students, potential energy. Last class we discussed the mechanical energy, and mechanical energies are two types. Number one, kinetic energy, and number two, potential energy. Kinetic energy, which included the moving object, and the potential energy, which included an object which one transferred from one place to another place. That means it depends on the object positions. So dear students, what is the definition of potential energy? The definition of the potential energies is you must listen to it very carefully. Dear students, the ability of a body to do work when its normal position is transferred from the other position. When the object's normal position is transferred from the other position, that means some other position, which one is the surface to the above 100 meter height or 1000 meter height. So dear students, it depends on the height. So we say that an object which one normal position and some other position. Dear students, normal position stays in the surface, and some other position which one is in the height is. Dear students, if an object moves from one place to another place, that means it travels a height s and which mass is m, then we say that the work done W equals F S. So dear students, we know that the formula of the F, which we discussed in chapter 3. Dear students, F, that means force, and we know that F equal MA. F equal MA. But when it included the surface to other places, or above in the place or outdoor in the space, then we say that the formula F equal mg, where g is called the acceleration due to gravity. Acceleration due to gravity or gravitational acceleration. Dear students, we use the term F equal mg. So now we say that the work done W equal to mj is. So we know the work done is equal to spent energy. You know that in the last lecture, spent energy. So here the work done is equal to spent energy, and which spent energy is included by the potential energy. So dear students, potential energy, which is denoted by or expressed as EP or V or U. Dear students, the potential energy EP equals to mgs. Now dear students, we discuss about the topics mass energy relation. Mass energy relation. If you don't understand my lecture, please contact with me and say it to me. Dear students, EP equal to mjs. Now we discuss about the key relation between mass and energy. The Einstein's formula, Einstein's formula E equal to mc square, which was related to the theory of relativity. From the theory of relativity, Einstein's expressed the formula E equal mc square. If the mass m and c, which is denoted by c, is the light velocity. We know that when we travel one place to another place, we have a velocity, and when the light is traveled, then light has a velocity. So c is the key light velocity, which value is 3 into 10 to the power 8 meter per second. That is, students, you must be understand these topics. If the mass m is transferred within the energy, then this is the formula for the energy, E equal mc square, and the object must be travel the velocity c. When we multiply the square of the light velocity in mass, we get the energy E. That is, friends, E equals to mc square. Now we say that E equal mc square, when we use this formula, we get this term in a reaction. Now you see that reaction. When we strike a heavy metal or heavy element, uranium 92 with atomic mass number 235. When you strike this element in a neutron, then we get that when you strike this element in neutron, then this element is excited. That means uranium 235, and when it excited, it gets the number 236, and this is called excited, and it's divided into two terms which atomic mass number about same, and we get that the term krypton and barium. You know that krypton, that means 36, and barium, that means 56. That is, students, barium atomic mass number 141 plus krypton atomic mass number is 92. That is, students, please remember that the atomic number 36 and 56, when we add, we see that the atomic number of uranium 92. But when we add 92 atomic mass number and atomic mass number 141, we see that the lacking of, or the less number of 3, or lacking of the atomic mass number is 3. Then we said that there produce a neutron, and which number is 3, and plus energy. This is the energy of the energy mass relation. So now we say that this reaction is also the nuclear reaction, and which is also said that the nuclear fission reaction. Now we say the principle of conservation of energy. Dear students, you know that the energy is not created and the energy is also not to destroy. It just transferred from one to another form. Dear students, so we say that the total amount of energy of the universe is constant and universal. Dear students, so if we said that and we expressed this principle, we said that the total energy E must be equal the potential energy and the kinetic energy. Then we said Ek plus Ep. So dear students, this is the principle of kinetic energies formula, and when we solve a question, when we solve the question of the total energy, kinetic energy and potential energies relation, or when we prove the conservation law of energy, then we must use this term potential energy, kinetic energy and energy. Dear students, we miss a topics which is energy. Dear students, here the energies unit we used MeV. Dear students, we must need to transfer this term, and we understand this term when we know the term M, E and V. Dear students, please listen to me carefully. M, that means million. If this term is 1 MeV, then we transfer this into the term J, that means joule. M, that means the million. So M, that means million, we said 10 to the power 6 into E, that means electron. Dear students, you know that the charge, the value of the electron, the charge of the electron is 1.6 into 10 to the power minus 19 coulomb. Dear students, the term V, which is the unit of potential difference. Dear students, the term V, which is the unit of the potential difference. You know that these terms is used in chapter 9 in class 8. Dear students, V, that means joule per coulomb. Dear students, you must calculate this term, and when we calculate this term, the coulomb C and C must be crossed. Then we say that the value of this term 1.6 into 10 to the power minus 19 and 6. If we vanish the term of 6, we get that 10 to the power minus 13 joule. That means the term 1 MeV is equal to 1.6 into 10 to the power minus 13 joule. It's very important for you. This term is very important for A type and B type. This term is very important for A type and B type. So dear students, this is the lecture of energy. Now, next class we discuss the CQ problem. Dear students, you know that this is very dangerous time period for us. So please stay home and stay safe. Allah Hafiz.